covering you'll find in lesson 104, and it's on page 13. And the guy goes through, and there's a little video snippet. Matter of fact, we went and watched it together yesterday during office hour. And he goes through step by step, and he kind of proves to you why it always works. So that's nice, but I just want to give you examples showing you why it works. I see we got some more people joining us, Travis and Lewis. Welcome. Okay, so what we went over in general session on Monday was when we have a sequence, we learned how to write a recursive formula and then how to take the information in that recursive formula to write an explicit formula. And then we did talk about partial sums, but what I didn't talk about was how there's a formula that works every time you have a partial sum. I talked about it just a little bit when I was talking to you about the population growth and so on in the slide that was after that, but I never wrote it out for you to see it. So we're going to go through this. So I'm going to start with part A. It says, no, that's just office hours, Jason. If you need help, come. If you don't, then don't come. It says, write a recursive formula for the sequence. And so what we have to know for that is, what is the first term? Can somebody tell me what the first term is in the sequence? 15. All right, we got that part down. So we know that this, oh, that's horrible. When I write small, it's just not a good business. So 15 is A sub 1. A sub 2 is 22. A sub 3 is 29. A sub 4 is 36. And the fifth term, A sub 5, is 43. So what I need to know now is what's happening in the sequence. Is it increasing, decreasing? How much is it increasing or decreasing? Daisy says it's going +7 each time. And we see that right there. So that's what our difference, oh, started to write the D again. All right, so we take that information and we use that to write our recursive formula. So A sub n, that's how I start my formula. We're going to take A n minus 1, because remember when we said recursive, it always depends on the previous term. So that's where A sub n minus 1 comes from, because we're dependent on that previous term. And then I'm going to add 7 to the previous term. So like for the first term, and remember n always has to be greater than 1. So the first term, I would plug in 15 plus 7 to get 22. Then I'd plug in 22 plus 7 to get 29, and so on. So there's my recursive formula. To get my explicit formula, and what we like about this formula is that it's going to work for any term. We're not going to have to know what the term is before, but we can still get the correct answer. So that formula, and you know what, I'm going to write this in a different color. In my last small group, I thought, you know what, if that was in a different color, it would be easy to see when I get to part C. For the explicit one, we've got A sub n equals, here again, I picked the wrong monitor. I'm going to take that first term, I'm going to add to it the difference, and then n minus 1. All right, so that means, oh, how Oh, good. We got more people joining us. Hello, Trinity and Priscilla. So A sub n, my first term is 15. My difference is 7. And then I'm going to distribute that 7 to the n minus 1. So that's my explicit formula. All right, let me go back to black ink here. So for part C, the formula to find any partial sum for a sequence, it has to be an arithmetic sequence, okay? This formula will find the sum, or partial sum, for any arithmetic sequence. That's going to be S sub n divided by 2, and then in parentheses here, I'm going to have the first term added to the explicit formula. And this right here, that whole thing right there is the explicit formula. That's an arrow. All right, so what I'm going to do here, I won't have enough room to write all this, so I'm going to take this formula up here and plug in all my numbers. I'm going to have the partial sum, that's what S sub n is, but I'm not going to put sub n. I just slipped. I got to replace all of my n's with the 100 because they're wanting us to find the sum of the first 100 terms of the sequence. So I replace all my n's with a 100. So I'm going to have 100 divided by 2. I've got A sub 1 is my first term that I'm going to use, so I'm going to put in a 15. And then on this next one, I'm going to plug in A sub n, which is my explicit formula. So I'm going to change colors here. And the reason I'm kind of pointing this out is because I want you to remember you're adding that first term again. You're adding that whole explicit formula. Remember I said everywhere I see an n, I'm going to replace it with 100 for this problem. Now at this point, when you're working your assignments, I would like to see this formula on your paper. And the reason is because if you don't give me the right answer, I can look at that formula that you wrote out and know that you plugged all your numbers in the correct place. That lets me know you understand what's going on, but for some reason or another you got the wrong answer. Or if you plugged in the numbers wrong, I can point it out to you and let you know so you don't make that mistake again. Okay, let me change my ink. So now, you could key this whole thing right now into your calculator. You just need to remember that when you're keying it into your calculator, always put parentheses around your fractions. This fraction's pretty easy. We know it's 50. But for the next problem I'm going to show you, it's not that easy. Okay, because you're going to get decimals and all that kind of crazy stuff. So, if we plug this into our calculator, y'all kind of look at that for a second. I've kind of got this problem memorized. On my calculator, remember I said I'm going to put my fractions in parentheses. So I'm going to put 100 divided by 2. And then I've got another parentheses. Remember, I got two 15s. 15, or that first term, plus the explicit formula. So that gave me 15 plus 15 plus the difference. Then in a parentheses, I'm going to put 100 minus 1. You got to put two parentheses. Because if you don't put the correct number of parentheses on the end, the calculator will give you an error message. And then I'm going to hit enter. So now I see that my answer, the sum of the first 100 terms is 36,150. So let me close this out. And then I'm going to write my answer down right here. Whoop. What did Josh say? Ended up looking up how to do it in my calculator because I couldn't find anything on partial sums. Well, just a reminder, because I know some of you weren't in here when I first mentioned it. If you go to the lesson 1.04 and read on page 13, they go through it and they kind of explain all this step by step and show you a real basic example. But I wanted to go through and show you a couple of more examples on how it works. Okay, let's look on the next page. I've got, and if you've already worked on your assignment, you know this is coming directly from your assignment, because I thought it was a really good example. I mean, yeah, example to show you, but it doesn't really matter that I'm helping you with it because it's all over the internet explaining it, because it's a real popular problem. This says if you save 1 penny on the first day of January, 2 pennies on the second day of January, and 3 pennies on the third, and continue with this pattern for the whole year, how much would you have saved by December 31st? First assumption here is it's 365 days. Afnan was in my office hour yesterday, I think, when we talked about all this. He knows I was stumbling through there. Okay, so the first thing that you're going to need to do in this problem is say, well, what is the sequence? So on the first day, let me I better tell that to snooze. I have a meeting right at 11 o'clock. And I don't want to forget it and not show up. They'll be mad at me. So the first thing I'm going to do is determine what my sequence is. So on this column is going to be my days, which is my N. Over here is going to be my number of pennies. So on day 1, I'm saving 1 penny. On day 2, I'm adding 2 pennies. Day 3, I'm adding 3 pennies. And we'll just go ahead and add the 4th one here. So I can see what my sequence is right there. So the first part, and I'm just going to write part A because I'm doing this exactly like I did the previous problem. You've got to figure out that recursive formula first. And to do that, what is my first term? It's 1. D, I'm writing that little d for the difference. So what's happening in my sequence? You're adding 1 each day. Well, I don't want to say adding 1. My difference is each day it's increasing by 1 that I'm adding. That's the correct way to say that. So for my recursive formula, remember, this is how we write it out every time. A sub n equals, and this A sub n minus 1 means I'm depending on the previous term. So day 2 is dependent on day 1. Day 3 is dependent on the term for day 2. And so on. And then I'm adding 1 to that every day. So that's my recursive formula. Now I'm going to also use all that information from part A to write my explicit formula in part B. So remember, for your explicit formula, say A sub n equals the first term plus the change, the difference in the sequence. So I'm going to put a D there. N minus 1. We'll be distributing that D to N minus 1. So my explicit formula in this problem, I'm just going to fill this in for you. You've already told me my first term is 1. You told me that D, the change in the sequence, was 1. And I'm going to be multiplying that N minus 1. And just leave it like that. Don't work it out yet. Okay, don't simplify it. Just leave it that way. So in order to find out how much money I'm saving, this is what you're going to learn about. It's a formula that works for any partial sum of arithmetic sequence. And like I said, that's in lesson 104 on page 13. And here we go. Here's the big formula again. You're going to take that first term and you're going to add it to your explicit formula. Just like that. So like I did, just so I have enough room to write everything out and I can write big. So now they want to know how much money we're going to have saved by December 31st, and we're assuming it's a normal year, no leap days, okay, or it's not a leap year, no extra day in February. So we're going to have 365 days. So we're going to, everywhere we see an N, we're placing it with 365. And remember, when you put this in your calculator, use those parentheses. I bet I'm going to run out of room writing this. Okay, I got to put that first term in there, a sub 1, which y'all told me was 1. I'm adding to that the whole explicit formula. Okay, so that means I'm adding 1 plus 1. There's so many 1s here. Oh, I did an N. Supposed to replace all my N's with 365. Minus 1. Now, if I write that out, I've still got 365 divided by 2. Now I've got 2 plus 365 minus 1 is 364. And I'm multiplying it by 1, so I'm just going to write 364. Now, if you were to, you can keep simplifying it and just say, oh, well, that's 366. And I'm multiplying that by 365 divided by 2. And that's, when you put all this in your calculator, you're going to get this answer. Well, I didn't want to put that there yet. Actually, you're not going to get a decimal there. What I want you to remember is you're going to get the answer is 66,795. But you got to remember you're dealing with money here, so you've got to move that decimal over 2 spaces. Okay, so does all that make perfect sense? Do y'all have any questions? Daisy's liking it.